So we're talking about hardware security modules. So I'll just refer to it from now on as HSM because it's a little bit shorter. And so we need to then give a bit of background on what is a HSM, why do we use it, what are the benefits of it, and what do we actually need it for in terms of like how do we interact with it, like what part of the communication kind of path do we need it, and yeah, maybe some kind of different types of HSMs, and then move into how to use it within it. So you may have heard this term already, like hardware security modules, especially like, or secure enclaves or things like that. So they're all part of like the HSM is the general topic of some kind of dedicated hardware component, which is then used to store sensitive information. So usually the storage of the sensitive information, we're not talking about, the whole encryption of your hard drive, and it's not like a huge data storage kind of mechanism, but it's instrumental in enabling you to like store, let's say, a private certificate or maybe identity in this chip to then maybe provide some cryptographic functions. So for instance, that could be used to, decrypt your hard drive, or in our case, we're talking about the storage and generation of the private key, which is required in the certificate-based authentication when we communicate with the cloud, and making sure that is stored behind this, nice little dedicated hardware module, which is tamper-resistant, and it provides basically cryptographic operations to use those keys. So those keys are not exposed to anyone. You can do cryptographic operations like in the TLS kind of way, a verify command, where it then says, I have this string. Can you please verify this against your key? The key will encrypt that input string and then return something. And then you can have the other end, like the server side, proving that, yes, that did come from that private key. So that's all using like the public key infrastructure kind of mechanism. So I won't go over that here, but it's more about basically not exposing your private key to anyone. This means you can't copy the key. You do not even see what the bits are in the key. So by doing this, why is this actually a good idea and useful? Is that because you have like the storage, like the secure storage of the private keys. So you can't then just go in and copy them away, or you can't actually view the contents and maybe do like, cat it and then copy the contents and go elsewhere. So it's actually impossible to copy the private key. So if there's questions, because I don't see the questions in the chat, feel free to just speak on the mic.
Oh, okay, sorry. So just for understanding, is this like the same or related to trusted platform modules?
Yeah, so a TPM is a type of HSM.
Okay.
Yeah.
Great.
So we have a nice diagram shortly, which will go into that. But basically, all of the HSMs have that common trait of not being able to copy the private key. And usually the HSMs also have some kind of like, they might have like, well, generally they do because they have to be, secure, will have like some kind of true number generator to generate that kind of private key, because that also, depends on the amount of entropy that you want to put into the private key. And so the higher the entropy, generally the better. So it needs to have like a random generator in there, or a random number generator in there to then actually make sure you generate a private key which is unable to be predicted, more or less. At least that's the goal. So in the context, some of the examples of like the HSMs. So as Mario said before, yes, a TPM 2.0, for example, trusted platform module. That's an example. You also have like from ARM, on some of the ARM processors, they'll have something called like a TrustZone, where that can be accessed. So that's kind of like I guess a secure enclave, which you can store kind of secrets there. Or like, minimal secrets, or use that at least to encrypt secrets on your disk. And that is exposed by something called opt. And you also have stuff which is like removable USB stuff, so something like this, like a Nitrokey, HSM2, or something like a YubiKey. So a YubiKey is probably more like user-facing, something like this that you plug into your machine, and then this provides some kind of like certificate or like the identity related to that. And as soon as you remove that USB thing, you don't have access to it. So, and also you still don't have access to the private key directly. However, you have to imagine that if you can remove it, you can kind of steal it. So yes, you can't do an offline attack. So you can't do like a once-off copy key and run away. But if you have physical access to the device, then you can obviously just steal the key. So it is generally recommended where you can that these kind of HSMs are somehow physically bound to the device. But it's more or less, the goal is to prevent an attacker from either spoofing it or from stealing it online. Because you can imagine that, somewhere in a different country, then it's harder to get physical access to the actual device because of geography. So you have to think about this. It doesn't solve every problem in the world in security. You still have to secure your devices physically, but at least it stops a whole host of attacks. So what do we actually use in the Finage part? So you can use HSMs for a whole host of different things. But in the context of Finage, we want to, at least at the beginning, limit it to one main function. And that's more or less the storage of the private key, which is used in the X509 certificate authentication when we connect to a cloud using MQTT that we used certificate-based client authentication. So we no longer want to touch your private key. That's fine. But we need to be able to leverage your private key by part of the TLS handshake. So when the MQTT client connects to the cloud will going, yeah, that's great. You've given me a public certificate. How do I know that that private key really belongs to you? So it will send us a verify message. We then send that operation onto the HSM, which does this kind of processing for us, and then gives us a response. We don't know how it got to that response. Yes, it was using the private key, but we have no way of generating that kind of, they call it a signature. So that's done purely by the HSM, and then we pass that back on the cloud, and the cloud then knows, yes, you're authenticated. Cool, you have proven that you're in possession of this private key. Everything's good, I can trust you, and then move on. And then you can establish the connection. If you can't provide that verification, then the server will not allow you to connect. It was saying invalid or unknown certificate, reject, and you'll get disconnected. So it's really nice mechanisms, but we're only focusing on that aspect. So now you may think HSMs, that's a category. Well, how do you know what HSMs can we support? So Finage is limiting the HSM support to purely something called the PKCS11 interface, which is also known as cryptokey, because I think that's the C header library. So this is the interface that Finage is using. And so that means you can check compatibility with your HSM. If it supports a PKCS11 interface, you can say, yes, Finage can support that. Or you can use it with Finage. So from a Finage point of view, it's quite easy at least, and because that does seem to be the common denominator for a lot of these kind of tools. So it should be quite easy to verify. But just keep note, or like keep in mind that, especially if you're talking about the USB kind, not all of them support the full host of PKCS11 functionality. So for example, the YubiKey, you can do the stuff that Finage needs it to do, but if you're looking to go beyond and you want to do like another private key generation using, GNU TLS and like some other tooling, some manufacturers just haven't implemented the full breadth of the interface. So that means that you'll have to use, the manufacturer's tools. So there'll be like usually CLI commands to do this, to be able to support it. And generally it's a kind of money thing, the more of the PKCS11 format they do, or like interface that they've implemented, generally the more expensive it is. So this Nitrokey costs 100 euros, whereas the YubiKey probably costs about 60 euros. However, a TPM module, which I'll also show later on, is about 30 euros. So for those who don't know what a TPM module kind of looks like, they come in many very shapes and forms. Ideally, they're soldered to the board, like the single board computer. But you can also retrofit some. So this is an example of a TPM module for a Raspberry Pi, where it's just a kind of chip which does all of the magic cryptographic kind of operations and that little thing. And you plug that in. I don't know whether you can, hopefully you can kind of see it. That is the TPM there that you just plug it into the header, and then that can communicate to the board and then do your cryptographic operations via that. So they come in many shapes and forms. We don't know all of the shapes and forms, so it's really, you need to make sure you read the data sheets from each of the manufacturers, and also find out what drivers you need to do this, because there's not one size fits all in terms of drivers. So that goes onto this nice point on the diagram, like how does everything kind of fit together? So on let's say you're using a Linux device. Generally, you're only going to have on that Linux device one type of HSM. So I just we're trying to visualize here that we're talking about, so in the end, you're just going to have this purple box, which you'll have a HSM. That could either be you have a YubiKey plugged in, a TPM 2.0, an ARM TrustZone. That's fine, one of them, but you're not generally going to have multiple. You can have multiple, we're not going to stop you, but in the end, we just need to know which one do we talk to, and that's a configuration thing. So with each of these HSM things, so there's also a soft HSM, which is good for kind of testing. If you don't have physical hardware, there is a HSM called soft HSM2, which can provide that interface or the PKCS11 format for you to then do your testing, so you can put that in system tests, fine, without actually requiring the hardware. But this is more for development only. That's not our requirement. That's just read the soft HSM to GitHub page. So with each of these hardware modules, they all have a common denominator. So that is a hardware piece of thing. In order for the operating system to even talk to hardware, generally you need a driver. Because they could implement whatever kind of signals that do different things and different input. That's really not up for us to define. But part of the interface is that this PKCS11 format or cryptokey format, there will be something called a shared object file. So in Linux, this is a .so file. In Mac, it's a dylib file or BSD. But in the end, it's basically it's a file which has a programmatic interface. So this is something that a piece of software loads to then talk to that piece of hardware. So these are more or less, as a general rule, there's basically a one-to-one relationship between, if you have a piece of hardware, you will have a different SO file. So for YubiKey, they have one like yklib something.so. Soft HSM has one, TPM 2.0 has one, Opti also has one. So all of these, there are middleware available which can kind of abstract some of these interactions. Yes, like OpenSC, but again, that's probably more of an advanced topic. But I just wanted to highlight this kind of one-to-one relationship, that it's in the end, the interface that FinEdge has to do is with a shared object library, which is dynamically loaded, and we need to know what one that is so we can actually interface with the hardware to do the cryptographic operations that we need to make all this work. So this is the interface. So we're not supporting, like, it's actually quite easy for us to support in terms of, as long as the PKCS11 format, we're good. Easy to also check. So how do we then do this with FinEdge? So the interface for FinEdge is we have a new component. So that is called a TEDGE P11 server. P11 is just a short form of PKCS11. This is the main mechanism and the only mechanism that directly talks to the HSMs. So to talk to the HSMs, it needs to load this dynamic library. So this, shared object file, which then knows how to do, the hardware related calls. So this component loads that library, whatever you have configured for your selected HSM, and it then provides a Unix socket that then can be used by the other FinEdge components. For example, the mapper. The mapper can use it to then, if it's connecting directly to whatever cloud, so Velocity or AWS, it then says, the cloud has asked me for verification on, is this my private key? It will then use the Unix socket to going, I don't really know much about this. I know I should be using the Unix socket, but that's about it. Sends the request on through to the TEDGE P11 server. It will do its whatever cryptographic operations was requested, and then it returns, and then you're connected. So the reason why we chose the Unix socket way of doing things is twofold. So one, we can have the same layout regardless how you deploy FinEdge. So whether you deploy here natively FinEdge running on the host, so on the same device where your HSM is directly connected to, or if you're running FinEdge within a container, the interface is exactly the same. So it should be really easy to switch in between the two if you want to, change your project design decisions midway through the project and going, oh, actually, we want to change from host to container or container to host. Doesn't matter, everything's still the same. Because this TEDGE P11 server is running on the host. So this is not really our requirement. It's just generally to access these hardware modules, you need to have host access. It's just the fact of life. You can potentially do it in a container, but in the end, you're going to have to give elevated privileges anyway to the container. And I'd go, well, that kind of reduces the benefits of running it in the container anyway, because you don't have privilege isolation there. So in the end, ideally, we would recommend that you run this component on the host itself, so natively on the device. So it's a separate package that you could install, and it will run a systemd service and socket and do all those things. And then it's really just configuring the mapper or like TEDGE itself to then use that socket for communication. Is everyone with me so far? Yeah. Okay, cool. So I know it's quite complicated, but it's the way it's done. So there's also a technique of providing the Unix socket. We didn't invent this. This is actually used by another GNU TLS tool called P11 Kit. So the P11 Kit operates in a very similar fashion, but with probably a little bit more like nested kind of setup. We figured, hey, let's write our own just to do this sole function. So that we can also improve the release process. Because under the hood, there are some build requirements which have changed for us because of this, and we didn't want to change how we were packaging FinEdge itself. We only wanted to limit that change to the TEDGE P11 server. So I'm specifically talking about either statically building the binary or not, or dynamically building, or statically linking. So we wanted to keep statically linked TEDGE, because that basically has 0 dependencies. And if you don't do a statically linked binary, that means you actually have a dependency on libc itself, which can actually be problematic in some instances if you're not in control of the libc version that you have on your device. Specifically with really, really old devices, that libc is only future compatible, not backwards compatible. So it just simplified by pulling this bit out into a separate service. Technically, we do have the ability to communicate directly, but I won't go into that without the TEDGE P11 server, but that has other build requirements, which I don't think in the standard setup of things is not applicable. But the socket is a really nice interface. It's the same for everywhere, so it's also very simplistic and flexible in different deployment scenarios. Okay, so I just wanted, with this step, wanted to show or highlight what is the difference when you're using a HSM or not? Like, where is my private key? What do I expect to be on the file system and when you connect to the cloud? So one of the major things before we go like where the private key is actually stored is this feature is only enabled if we're using the TED mapper's built-in bridge mode. So this is a shift from using the default or the current default, which is using Mosquito Bridge as a communication to the cloud. For a while now, we've had the ability in TED mapper itself to connect directly to Commodity and act as the bridge. And this is called a built-in bridge mode. So this is only enabled, like using HSM, is only enabled with the built-in bridge. So the reason for this is a bit of like a strategic shift for us to lessen the dependencies to Mosquito. Because over time, we've noticed that the Mosquito bridge functionality has had more and more kind of limitations that we've either had to work around or, you know, build our own versions and all this stuff, which is getting more and more complicated. Whereas if we're in control of the bridge ourselves within the TED mapper, it's much easier to reason with from a conceptual diagram because the mapper is connected directly to the cloud, more or less. But it also leaves us to be more flexible to do, you know, potential new features like supporting HTTP proxies, which is, I know, a hot topic at the moment. So with this, so it kind of goes into that messaging. At some time this year, we will change the default to using the built-in bridge as the bridge connection, and then phase out the Mosquito bridge. But I think for a long time, because everyone's using the Mosquito bridge at this point in time, we will not be deprecating that anytime soon. So don't be worried. It should all still work as before, but we just might switch the default. Okay, so when you're using a HSM, what does that mean for your private key and your certificate? So if you're not using a HSM, as now, which is the default, you have your public certificate, which is the public information. So there's no security risk if that gets exposed because it's a public certificate. It's meaningless without the private key. Then you have your private key. So both are sitting on the file system. They're protected by permission, so it's not like they're unprotected. So, but if you have a device which gets compromised and someone gets root access to your device, technically then they can steal your private key and then, you know, copy it offline to a second device and then spoof your device basically with your connection to the cloud. In the end, it's probably not that super critical, but, you know, no one wants this to happen. So you should definitely try to prevent it as much as possible. So with a HSM, nothing changes with the public certificate. That is on the file system as was before, because that is not sensitive. And it was a little bit of a conscious decision to actually leave it on the file system, because as part of like the certificates, it's important that everyone knows what the certificate is, or if you want to get some meta information by using additional tooling, you kind of want to know, you know, what's the common name of the certificate and maybe when does it expire. Then by having it in the file system still, it makes it a little bit more accessible to then read meta information about it. So that hasn't changed. The only change is that now the private key has moved from the file system, so it was down here, up into this HSM. And because it's moved into the HSM, it's not directly accessible. We now then need to go through the THP11 server to do whatever cryptographic, so assigning. On the file system, you're still going to have this shared object file. So there's PKCS11 you know, object file, which is used to communicate to the hardware. And then we can do whatever operations that we need when connecting to the cloud. So again, this is part of the TLS 1.3 handshake process. Yeah, so it's a big shift. You will not see a private key then on your file system. So everything never leaves the HSM. I mean, it's up to you to kind of, you know, do the private key. But by not even knowing what it is, that's the #1 advantage of the private key. I like being stored in a HSM. Okay, so we'll go shortly into the demo, but maybe just one thing that definitely caught us out with a few things. Just because you have a HSM doesn't mean all of them operate exactly the same. So different HSMs will have different requirements. So generally, more specifically for TPM 2.0, you'll need to check that you need to add like the TED user to the specific group. I think it's called TSS. So there's some kind of like each kind of variant of the HSM will have different requirements of how to interact with that. Sometimes it's set through environment variables. Sometimes it'll be, you have to make sure you add a specific user to whatever Linux group, so you can then even access that hardware. It really is dependent on that. So we will try to guide users to the best of our knowledge onto, hey, these are kind of like sensible defaults. But because we can't build that into the actual, Linux package itself for the TEDP 11 server, there is an initial kind of setup. But in kind of like production projects, you'd be having this part of like your build automation system. So when you're building your image, you'd be setting this, hey, I know I'm using TPM 2.0, whatever manufacturer, install the drivers, make sure TED is added to the appropriate group. So just be aware there's different ways of different requirements. So that's why reading the documentation of your HSM manufacturer is mandatory. We can't solve that for you. We can't read that manual for you. You have to read it yourself. By all means, we're happy to accept, community plugins which help users set sensible defaults for different TPM or like different HSMs, by all means. But, we can't put everything in the core product because it just varies too much. Okay, so let's jump into actually looking at some things in action. So these documents are currently work in progress because it's quite a complex topic to explain, and also a little bit to configure at the beginning. But again, this is part of like your image building process. So we're still refining the docs. But in the end, it's more or less, you need to install that component. You need to configure it to saying, what is your shared object library, a PIN associated to accessing that hardware security module. This is not really a password. This is more just an additional layer on top. I wouldn't say it's super sensitive. You should still try to protect it if you can, but it's not a super sensitive information because you still need physical access to the hardware. And you cannot export the private key, or you shouldn't be able to. So it's not super serious if that gets compromised. Then you have to enable the socket mode to inform that ThinEdge should use the socket for interactions with the HSM. So that's basically our flag to say, you want to use a HSM. Okay, we need to then communicate with the TEDP 11 server socket. And as I said before, the enabling of the built-in bridge to then facilitate this communication. So if we go into my device at the moment, so I'm actually connected already, show, with a TPM module. Now, if you do the TED search show, at the moment, we don't really show much information saying, hey, you are using a TPM. But if I just look in where these files are, so it tells me where my public certificate is. So that's fine. I can show that to everyone. So I'm looking in the file here. And you'll notice there's no TED private key.pem anymore. This is because that is stored. So on my device, I've plugged in a YubiKey. So that like the private key is there. It was generated on the YubiKey, has never left the YubiKey. I can't even export it. That function is disabled. It's purely, it's not accessible. So if I do a reconnect, I can kind of see some signs of life that it is actually using the cryptokey kind of interface. So here, firstly, I can see that at the moment we have a Boolean, but we'll be changing this before we do the next official release to indicate, yes, we are using the cryptokey. And what bridge mode are we using? We're using the built-in. So you can already see, okay, there is a few kind of telltale signs there to indicate that I am using this kind of hardware security module. But apart from that, everything just works like as before. So there's not really too much to kind of see. So I can, everything just kind of works more or less out of the box. So what I have, I didn't show that. So I already started the TEDGP11 server here on my machine, which configures, what socket do you want to start? So Unix socket. What module do you want to run? So because I'm on Mac OS, it's actually a .lib file, but on Linux, this will be a .so file, which basically tells, how do I actually interact with this HSM module? I need to know what kind of, shared library or shared object library I need to use to be able to interact with this hardware. And that's it. So I'll just show you another demo before I go into, well, how does this interact with other systems? So if we look, I have also a device here, which is running a TPM2 module. So it is a Raspberry Pi device. So I can see that the server.socket. So because now I'm on Linux, we have a systemd service. So there is a socket, which then calls a service once the socket is used. So if you install this package on the device, it will not automatically start the service. It will only start it once it's being used. So this is called socket activation. It's a systemd feature, though other Linux, it comes from a very old Linux concept of socket activated services. But it's basically a efficient use of resources, because if you don't have anything that uses it, it takes up pretty much next to no memory. So if I look at the service here, okay, because I've started it, it's running, so I've already got an indication, yes, I have something using it. But if you first install it and haven't started anything, then this service will actually be stopped. So there's nothing really to manually start, which is the great thing. Once you configure it, everything should just magically work, which is the nice side of it. And because I'm using, so at the moment we have a configuration file. Again, that will change to a TOML file eventually. So at the moment, the way to configure the TEDGP11 server is just basically a .env file, which is just a list of environment variables that should be set and then used by the process. So here I've defined that what is my shared object library that I want to use. So because of TPM 2.0, they have a TPM 2.0 pkcs11.so file. What pin have I configured on my TPM 2.0? I've just configured the 1, 2, 3, 4, 5, 6. That's fine. Again, you need physical access to even use this. And again, you can't export the private key. Now, the TPM2 also has an additional kind of requirement that you need to set an additional environment variable to know, because it stores, I think, an SQLite or a file, which is a database, on your system, which I think it probably does a public key lookup, I'm guessing. So there's, depending on the HSM, some have different requirements, and this is one of the TPM 2.0's requirements. So that has nothing really to do with ThinEdge. It's just part of that technology being used. You have to set some additional things. So on the setup, I've just decided to create this folder to put it in, and you can see the SQLite file here. So this is something created when you create the private key and do these kinds of interactions. It's just created by the system, or like the TPM2 mechanism. So let me just connect here. If I connect again, oops. Let me just check. Probably done something silly. Reconnect. And then server. Yeah, there's a few kind of small things here and there which we're still going through before we do the official release, just to make it a little bit more robust for a few kind of corner cases. But in the end, you can kind of see here cryptokey, and then the built-in. So it's kind of been established, and it seems to have a bit of problems connecting or verifying my connection. But in the end, that's kind of like the rough kind of setup of how everything kind of interacts together. And these kind of like small things that we sorted out during the before the official release. So now, then you might ask, well, how do I actually use this in production? Because maybe you want to. So last time I think we demoed the what was it? The certificate authority. So there's upcoming Common certificate authority feature, which makes it really, really nice to onboard your thin edge devices or other devices, non-thin edge devices, using the new certificate authority feature in Common, which basically adds a new way to enroll your device, but also renew certificates, which is the magic feature that everyone is hopefully going to really love. So with that, then the question is, well, how do you actually then interact? Does that work with HSMs? Because generally with the HSMs, that will be in response, like somewhere in the process to actually generate the certificate signing request. Because with certificate signing request, you need access to the private key. So that's why part of the PKCS11 interface is that, and there's like cert tool to do this, can interact with the private key or with the HSM to saying, hey, please give me a certificate signing request or do whatever kind of encryption you need to be done. And then that will produce the certificate signing request. So I'm just going to demo that in here because I've prepared a few things. So I've just written a script which basically looks at, so I'm going to be onboarding the device natively on my Mac, but it's kind of same process. So here I'm just, so I already have the TEDGP11 server running. And let's just change that for fun. And what I'm going to do is, so I'm going to do an enrollment. Oops, if I copy the whole command. So this will be my new device ID. I want to do a registration. So I could also do this through the UI. I'm just doing CLI commands. So I can create a enrollment token that I can use then on my device to then actually enroll it securely in the cloud. So that's using the new certificate authority feature. Now, if I just take this TEDGP11 cert, all of this is doing is basically a lot of PKCS11 tooling on top. So for example, the GNU TLS utilities will have a few kind of like generic CLI commands, which you can also use to interact with PKCS11 or HSM module via the PKCS11 format. So whether that's getting some information about it, initializing it in some aspects, like for TPM at least, you can generate the private key, but again, it depends on what has been implemented by the HSM. But more importantly is after you've created the private key, you want to create the CSRs, so the certificate signing requests. So the cert tool is great for this. So you can generate the certificate signing request and then pass it to down here, the Common commands, so like the TEDG commands, which will use the new Common interface. To then, so here, when we're creating it, we can download the certificate using our enrollment token and also the CSR path, which was generated by the cert tool. Because that is then capable of reading from the PKCS11 format to read the appropriate key, and then everything just kind of works nicely. So if I do the enrollment now, and I'm just disconnecting because I was previously connected. It's now, so let me just make that bigger. So it's now download the certificate. Or yeah, it's actually downloaded and connected. So everything worked fine. And then I now have a new device, which is registered in Comosity. Let's go here. I was playing around with a few different ones. This is now my device that I just registered. So it's compatible with the HSM. That's fine. That's through the P11 tool and cert tool, which are GNU TLS utilities. Everything's available then to work, and I can then request, hopefully, the configuration, for example. So and then the normal functionality. So here it's just using Brew as a SM plugin, for example. So that's available. Now, how do you renew? Well, it's pretty much the same process. So you're still using the the cert tool to use to interact with the HSM to do the CSR generation, and then you just pass that to the TEDge tools, which know about the new Comosity feature, and it's pretty much the same thing. So instead of just do here, so again, this is just a utility that I created to help me demonstrate all of this because it's a little bit complex to get the right commands up. But it is quite easy to integrate with additional proven tools, which all work. And here I've reconnected now with, and I have a new certificate. Let's show. So this was renewed just now. And this is the serial number from the new certificate. And I can see that it's signed by the new certificate authority feature, because that's then linked to the common name is then the tenant name, which I'm connecting to. So all of this, I know that was probably a lot of information, but I think even just kind of knowing roughly about the topic and how I'm doing it, we'll be improving the tooling on top and the documentation as we go. So don't be shy about giving feedback about it, or if you had tips that you found out, I ran into this common problem, then feel free to create a PR to add that to the documentation or a ticket in GitHub. That's what all open source collaboration is about. And if we deem that maybe the script might be useful, we might add it to some different kind of community plugins that you can kind of then base your solutions upon. So I originally created it as part of the Rugex recipes to try to demonstrate this and then install all the dependencies which are required to get all these things up and running. So any open questions?
Very cool. Like to see it. So the cert tool you said now also is able to interact with the HSM to read the private key, and it does this by.
So technically, it doesn't read the private key. It asks the HSM to create whatever, or the CSR as part of that. I'm not 100% sure. I don't think the HSM is actually creating the CSR, or it might be, but whatever cryptography or cryptographic operations are required to generate a CSR, it does that part. So it knows how to reference the private key, because the tools need to know what private key are you talking about. So there's usually with the PKCIC 11 format, there's actually a URI, which is associated with the key. So that might be actually useful to kind of point. P11 tool list token, if I can spell. So you can see I have quite a few kind of tokens configured on my machine. So here, or a URL, this is referring to my YubiKey, because I know how to refer to it in this instance. But you can see here, I've also been playing around with the soft HSM. So you can actually use this in multiple ways and have multiple things. But in the end, whatever tooling you're using you need to know which key am I referring to. So if you need to do any kind of cryptographic operations, like generate a CSR, you give it a reference to that, and then that's part of the PKCS 11 format or interface, there's a list of commands basically, and then it knows what to do with that. So it's basically proxying that, like the cert tool knows how to then interact with those components.
Okay, got it. Thank you.
Yeah. So specifically, so the cert tool on Mac, it's a little bit different because there's also a BSD cert tool, but I'm talking about the GNU cert tool here, where you basically this load private key, and you specify this key is actually a URL referencing to the private key. And generally, you also need to specify the public key, which is not the certificate, it's the shareable component of the private key. So it's basically how you can kind of reference, and it's generally, I think sometimes part of the PKCS11 format, sometimes you can actually get that public key automatically through the PKCS11 format. But I think YubiKey can't do this because they've only half implemented things. But I'm pretty sure if you use something like a Nitrokey HSM2 or a TPM, that can probably do it without their private key. But don't quote me on that. Sorry, the public key. Cool. So if there's no other questions, then hopefully just remembering some of the buzzwords at least, and roughly knowing it is something that customers are asking for, and it's generally will be more and more kind of, and I think regarding to the Cyber Resilience Act, I believe even maybe usage of HSMs may be mandated. Don't quote me on it, but or strongly encouraged, if not mandated. But at the moment, it's not all chips have this out of the box. So it's a kind of like a middle ground that maybe you have to kind of, add a new component to it, or worst case, add a USB and live with the physical kind of limitations there. You can just remove it. But this will be more and more kind of coming up. So at least being familiar with the topic, I think is beneficial to everyone, your customers, or even your own customers, because they'll have the same questions. Cool. Then thanks for staying with me there, and don't be shy about asking any kind of follow-up questions later on Discord, GitHub. You know how to contact us.
Yeah, I actually have, let's say, 2 questions, Ruben.
Yeah, sure.
They are not so very technical, I sort of left the time to the others, let's say, to have the chance to ask something specifically. I found this very well explained, so thanks for that. My question is, let's say, how do you get the initial token to Cumulosity? Because, I mean, also previously when you created your own certificate, you had to use your own username password, which is a bit better than the Bootstrap credentials, but ultimately still not certificate-based. So it becomes a round story when you kind of one step ahead and actually request, let's say, HSM or TPM modules that use the same source certificate, right? So that you use that to upload to Cumulosity. Is that true? Otherwise, you always have the problem of using credentials to kind of get the.
So this is, I would say, this is purely the certificate authentication. Certificate authority feature from Cumulosity, which will be in public preview shortly. Which is basically, so if you look at the demo from 4 weeks ago, Didier does a nice kind of demo of that feature, but just to kind of summarize that in 2 sentences. So, and I can actually probably show it to some degree. So with the new feature, so I can show it's enabled on my tenant. So here I have now I've hit this button and I've added a CA certificate, which is a Cumulosity per tenant special certificate, where there's a backend process which knows how to handle that and sign new certificates and give that to devices. Now the question is, how do you give that to devices? So this is all documented in the OpenAPI. So if you go to the OpenAPI spec and look at latest, you can jump down here and you have device enrollment, where you go into, how do I do this? But I can give a kind of a short summary. So it's similar to, if you're familiar with the bootstrapping process of Cumulosity, like the, let's say the classic MQTT mode, it's very, very similar to that, but it is about 10 times better. So you would go here, like you can automate all of this, just doing an example because it demonstrates it nicely. I can go my test device. Give them the device, or maybe that's probably a better name. That's my device ID. I can give it a one-time password, which is only associated or valid for that device. No other device can use it. So this kit.
So let's say device-specific bootstrap credentials, so to say.
Yes,
yeah.
More or less. But it's a one-time thing. As soon as you request that, that password is gone. So it's only valid for that initial, getting the initial certificate. And then what under the hood, it's actually using EST standard, so enrollment over secure transport, where it's doing a CSR from the device side as part of that request, using this kind of like, you can manage the keyboard or something like that. Let me do something a little bit more producible. So you register that, you need to make sure you know what that is. I now have my request here. It's fine. I'm probably going to opt out of my, can I do this? Download. Because I'm kind of in between worlds at the moment. Config, set, device, cryptokey, mode. I'm just going to turn cryptokey off for the moment, just for demonstrational purpose. Okay. Set. Download. I forgot the argument. That's why it wasn't working. What did I call it? Test 02. Now that is my one-time use password. We don't dictate how that is generated, so you can actually do like you could derive that token from the ID if you wanted a calculatable way, and then part of the enrollment process, you put that into the cloud, and then both know how to generate that from the type. Could be a fixed password. I probably wouldn't recommend that, or just like a randomly generated. And if I go now there, it's done. So show, I now have so it hasn't connected yet. I've just downloaded the certificate, so I'm not like connecting to Cumulosity with it yet. But that is a new certificate issued by that. If I try to use that again, it just said, well, we couldn't find that device request, because if we go into the UI, that's gone now. So the test underscore 02. So it's a really nice mechanism because it's simple. It is secure because, remember, this is a CSR request going on in the background. So if someone else intercepts that, that certificate is useless without the private key. So you're going, oh, cool, I have a public certificate, but it's public, who cares? So they can't like intercept your request with something valid, which is usable afterwards.
Okay, so you're saying even though it's username password, it's more secure than username password, or
absolutely. Like it's just an authentication to get a protected resource, and because it's one use, it's really like there's no hard coded. It's a magic password that everyone uses. No, you can do what you want with it. So technically speaking, if the device ID is complex enough, that is pretty much like a password, right? Because it's a combination of username and password. So if you don't have predictable serial numbers, that has some degree of entropy, even though probably not technically entropy because they're probably based on manufacturing times and whatever. But it can be unique enough for this one-time operation. And then you know if someone else has it, because if your request fails, you know someone else is maybe accessing something that it shouldn't be, or maybe using the wrong device ID or whatever.
What is your vision for an ideal, secure, integrated device partner, right? So I imagine my perception would be the device partner manufactures the TPM, and they use, I don't know, a CA certificate to provision all of these HSM modules, and they ideally upload the same CA to Cumulosity. So there is no, let's say, requirement for the step you just described. Does that make sense, or is it?
There is, like, you still need that initial certificate.
Yeah, you need to upload it in a secure way. Yeah.
So you can do this in the factory, and that's probably like the easiest way. Do it in the factory, so when you ship those devices, they're done. But yeah, if you have your own CA, you can continue using your own CA. That doesn't change anything because you've already done that process, and then this feature isn't for you. So it won't, like, it's really up to you what makes sense, and the project makes sense. There is no one solution that works for everyone, because there will be different kind of non-functional requirements or even functional there to make all that work. But if you don't want to pay for a PKI provider, because all of these cost money per device, generally speaking, per month, this is free, secure, easy, cool.
And what's the guidance on, let's say, replacing, I don't know, certificates, or maybe just, let's say, public keys from the device? Because initially, let's say, when you created your own CA for until this feature was available, the certificate expired after a year, right? How does it now work? Or what's the best practice? You're like, will the certificates cannot expire? They're an HSM module, right? It's always the same.
Expired, you have no way to contact the platform, so it's expired. So that is with everything. So you have to do the onboarding again. That's fine. Like it's a simple onboarding process. Ideally, but the good news is, so this is like a totally different topic, but I think it's still relevant for everyone. So if we've had customers which have issued a self-signed certificate, maybe not using in production, but like on the road to production, and they're using already self-signed certificates. For these, the prerequisite to renew a certificate, this could also be it never was under the Cumulosity CA, but you want to move it to under the Cumulosity CA. The process is exactly the same. Because if you have a connection to Cumulosity already, the authentication to renew a certificate just requires a JWT, which ThinEdge will do out of the box for you. So you can actually transition from a self-signed certificate to a Cumulosity CA issued certificate without doing anything. It just works. So there will be a renewal service which does the automatic renewal. So there's no manual things to do anymore. That will do it automatically. But the only thing, maybe if you want to activate the transition to saying, please move it now, you can then manually trigger the renewal process as well. So then saying, I don't want to wait until my self-signed certificates are, within 60 days of expiring. I want to renew them now because I want to, in the end, remove all these individual certificates and replace it, just have one trusted certificate, which is the Cumulosity CA. So it'd be a similar process if you have a different CA and want to transition to the Cumulosity CA. Exact same process.
Would it be possible if you could demo that somewhere? I know it's not a ThinEdge demo in that sense, but
so it's being announced. I'll actually be giving a demo in the What's New thing tomorrow about this, and we will definitely be having a section on that in the docs as well, because it's not yet public preview, so it will be only on-demand requested public preview at the beginning. Before it goes into GA. But all of this will, so I think the good messaging for all the customers and pretty much anyone using certificates, your life will be much easier. You do not need to worry about expiring times again, because if you're using the CA feature, it will just happen automatically. The onboarding will be much easier. You're not using your credentials anymore. You'll just be using this one-time generated password. You can also do this in various ways. You can get the device to generate for you, like put a wrapper script, and you copy that from the device to the cloud, or the other way around, because in the end, both sides just need to be talking, like expect the same thing, and then it works. So maybe if that's not 100% clear, this is still running in the background, requesting something, like requesting the certificate. But because that one-time password's already gone, I just need to, copy that again, that same thing into the cloud. If I hopefully am fast enough. Just device test. Was it 002? Yes. Next. It will try every 30 seconds, but you can control that as well. The next time it will then get a certificate because it's sending, it's finished already. So it's doing a CSR. It's not saying, hey, please give me a magic certificate and private key. No, it's sending a CSR request. So if something else intercepts it, it's useless without the private key. So that's like the security mechanism. And that's, if you want to read up on the EST spec, yeah, and there's the RFC behind it, which explains it.
Okay, perfect. Yeah, that's, I think, the missing information. Yeah. Perfect.
Yeah, but yeah, so I think that is a very, very positive messaging, both for Comvelocity and Thinedge, because it's basically everyone's had this question, and yeah, so the future will be better and easier and cheaper.